Hello friends, welcome back to my channel. I hope you are enjoying my new videos. So today I'm going to discuss a very important feature on how to determine your organic compound structure based on your IR, NMR, like carbon NMR and proton NMR, and also like mass spectroscopic data, and sometimes you also will be given like UV data. So based on that, how you can solve your problem. So before going to solve those structure, we need to know a little bit basic about the approaches, like based on your SODAR number, your IR functional groups, and from the proton NMR and the carbon NMR, the information we will gather together, and then we will just put together all those pieces we get from those NMRs, IRs, and the SODAR numbers, and then probably we can able to determine the structure of the molecule from the formula. So first of all, before approaching, very first approach is your SODAR number, or like double bond and ring, like unsaturation presence in your structure, that is called double bond or triple bond, and also the ring. So let's see about that. So we write in short, we write as a SODAR. Summation of double bond and ring. So that is called SODAR number. So you can, some people also say like unsaturation number. So what is exactly this mean, and what are the information we will get from the SODAR? It is very important for first step to determine the structure. So so suppose you have a chemical formula as CXHY. So for this, you can get the SODAR number. So it should be X plus 1 minus Y over 2. This is the rule. Just X is the carbon number and Y is the hydrogen number. So X plus 1 minus Y over 2. So by this way, you can get the SODAR number of any molecule. Suppose you are given, so C2H4, to find the SODAR number for this. So if we put the X value as a 2 plus 1 minus Y value is 4 over 2, so it will be 2 plus 1 3, and 4 by 2 means 2, that means 1. So for this structure, SODAR number is 1. Now if you have and what this number means, I will come back. So just now learn how to find out the SODAR number for different kind of molecules. So this is for simply hydrocarbon, just law is this, okay? Now if you have oxygen in the molecule like CXHY, and oxygen is Z, like number, another number Z, so CXHYZ. So in that case, how can you calculate the SODAR number? So remember that your molecule can be three different ways, especially the organic molecule CXHYO, CXHY, halogen, like chlorine, or CXHY bromine, CXHY iodine, or this number can be like different, like more than one also could be. So in that case, if you have the halogen and there is another kind of organic compound, you will see that is CXHY nitrogen Z. So one type is like purely hydrocarbon, carbon and hydrogen, Another type is halogen, CXHY, halogen, like chlorine, bromine, iodine. And another is like nitrogen. So all those three cases. So remember that for the oxygen part, it will be the same as the hydrocarbon one. So the equation will not be changed when you have the oxygen in your structure. Let's see an example. So if you have suppose you have a molecule C3H6O, okay? So for this, just calculate the soda number here, put the equation, and again, for having the oxygen, that hydrocarbon equation will be the same. So it will not be changing. So for this, x value is 3. So 3 plus the equation 1. So equation 1 minus y is 6. So 6 divided by 2. So 3 plus 1 is 4 minus 6 by 2, 3. So again the soda number 1. So for this molecule, you will get the soda number 1. Okay? So I think till now it's clear. So any structure CXHY and CXHY oxygen. So for those, the equation will be the same. Now, let's do for the halogen and the nitrogen. So SODAR equation for the halogen containing compound and nitrogen containing compound. Nitrogen containing compound. So suppose CXHY, this is X as a halogen, this is Z, okay, and CXHY nitrogen Z. So for this halogen, the equation will be same as X plus 1 minus Y plus Z by 2. So this number Z, just sum up with the Y. So similar like the previous one, just add the Z with Y, then divide by 2. And for the nitrogen, it will be CXHY. Oh, sorry, the SODAR equation will be X plus 1 minus Y minus Z by 2. Okay, so you want to see the example, right? Let's see. Let's see for the nitrogen. For this, what is the SODAR number? So X value is 5 plus 1 minus Y value is 4 minus the N, like Z value is 1. So you can put 1 here divided by 2. So 5 plus 1 is 6 minus 4 minus 1 is 3. So maybe it will be like 5 actually. So let's put 5. 5 minus 1 by 2. So 6 minus, so 4 by 2. And that will be 6 minus 2. And actually it will be 4. So definitely you can predict the structure. It is a pyridine structure. So for pyridine, soda number 4, how and why it is 4, I will explain. Just now try to learn the equation and how you can find out the soda number, or like number of double bond and ring, or unsaturation, number of unsaturation carbon, like double bond or triple bond. Okay, so for this molecule nitrogen 4. Okay, so if we do for the halogen molecule, so now suppose your molecule is C4 H6, not 6, like 8, 7, and 1 bromine. Okay, for this, so the number is, X value is 4, so 4 plus 1 minus, and it will be Y plus G, so Y is 7 plus Z means like here is 1, so 1 divided by 2, so 4 plus 1 is 5 minus 7 plus 1 is 8 by 2, so it will be 5 minus 4 equal to 1. Okay, so this is I think you guys already understand. If you have the halogen in your molecule, just add the number of Z here over 2, and then you can easily calculate the SODAR number. If you have the nitrogen in the molecule, just subtract the Z. And one good technique to remember, like in which case you will add and with the Y, and in which case you will subtract or make a negative with the Y. So remember that nitrogen start with N, so negative, so you can just put a negative sign here, Y minus Z, negative. Okay, and halogen, it's like a proton, hydrogen. Okay, proton is positive, so you can just remember that, add the number Z. It's like just to remember a technique, nothing like serious. Okay, especially for the nitrogen case, just subtract the Z value, that's it. Now once you know the number, you can find out the number, like SODAR number, how or what these numbers actually signify, like what are they saying. Okay, so for this molecule, actually for this molecule we got number 4, okay, and for this molecule we got number 1. So if your SODAR number is 0, so in that case, in that molecule there will not be double bond, no triple bond, no ring. Okay, now in case of so when your SODAR equal to 0, no unsaturation, no unsaturation, no double bond, no ring. Okay, but when it is SODAR number is 1, then you can consider one double bond present there, like one carbon-carbon double bond must be there, either this or a ring. Like what? So suppose cyclohexane, this is a ring, right? Or like cyclopentane, or like cyclobutane, those are the ring, but there is no double bond. So for a ring, SODAR is counted as 1, and for one double bond also counted as 1. So if you have SODAR number 2, then you can say either you have 2 double bond or 2 ring, or 1 double bond and 1 ring. 1 ring means like this kind of ring. So either 2 double bond or 2 ring, or 1 double bond, 1 ring. Okay, if you have SODAR 3, then you can say, oh, there is another thing. If you have SODAR number 2, then you can also consider 1 triple bond, like alkyne. If you have 1 alkyne, you can get the SODAR number 2, because for one double bond, SODAR 1. So since it is a triple bond, so another double bond equivalent to another double bond, so you will get SODAR number 2 for a 1 alkyne. So if you have 3, then you can say 3 double bond, okay, and 2 double bond and 1 ring, and 3 ring, and 2 triple bond. No, not 2 triple bond. So that's it. So 3 ring, and you can also say two double bond or one double bond and two ring. Okay, clear cut. So now, in like, give an example. Suppose you have a cyclohexane. Okay, so can you tell me what will be the SODAR number for this molecule? Yes, you're correct. The SODAR number for this molecule will be 2. Why? Because one double bond, SODAR 1, and one full ring, so SODAR another 1. So total 2. So for this molecule, SODAR will be 2. Okay? Now, if you have SODAR number 4, that is interesting. So in that case, you will immediately consider, if you have SODAR number 4 or more, okay, so first time, just keep it in mind, you have an aromatic or benzene ring. Might be, okay, most of the case it is true, like if you have 4 or more, like 5 or 6, okay. How? So if you think benzene ring, so full ring SODAR 1, and it has 3 alternate double bond. Okay, so 1, 2, 3. So 3 double bond contain 3 SODAR, including 1 ring, total 4. So if you have SODAR number 4 or more than 4, so you can consider, keep in mind, yes, maybe in my molecule I might have a benzene ring or aromatic ring. Okay, so it is a like common technique. Another thing is, for these 4, you can also think like you might have two triple bond. Okay, so each triple bond SODAR number 2. So 2 triple bond SODAR number 2 times 2, 4. Okay, and you can also say you might have 4 double bond. Although it may be very rare, but in many cases, conjugated double diene, trine, tetraene, you might see like 4. Organic structure to solve with the spectra, maybe it will not be given like with the 4 double bond, very rare, okay? But mostly if you have the 4 or more, then you can consider like 4 of them will be gone with the aromatic ring. So that is very important. So now I think you have a very common, clear concept about the SODAR number or like double bond or like unsaturation number, how you will get to the molecule. So this is the very first step. So this piece always will give you first impression like what is your molecule, either double bonded or triple bonded, or it might have ring, or it might have the aromatic ring. Okay, so this part is done for the SODAR. Next step will be IR. So from the IR, clearly we will get some pieces of information. In my next video, I will start with the IR, and like I will try to make the small video on that so that you people can keep patient to watch the whole video. So this video will be on the SODAR number, next video will be IR, and then next video will be the NMR, the basic, and the fourth video will be like solution or solve of the chemical structure based on all those informations, like your SODAR number, IR, MS, proton NMR, carbon NMR. Okay, so till now, stay fine. Bye now.